So I am Dr. Manoj Kumar Biswal. It's my pleasure to introduce Dr. Goutam Das, a distinguished science and analytics thought leader with decade of experience. He has spearheaded a startup analytics firm, served as global head of business institutes like IIT Kharagpur and IIM Kolkata. He has also led nationwide analytics competitions. Dr. Das specializes in leveraging advanced statistical, mathematical, and AI-driven methodology to solve complex business challenges, combining academic rigor with practical expertise. Yeah, I'm welcoming Dr. Gautam Das for this section. The stage is yours, sir.
Okay, are you able to hear me?
Yes, sir, audible.
Yeah.
Yes, sir. We can hear it.
Hello. Yeah. So, welcome to this session. I must thank to be invited here to address you all. And it was a short notice. Actually, I was flying today only. I fly into Mumbai. I was traveling for last 2 weeks, and the date has been decided because of my unavailability beforehand. So today, I just couple of hours back, I landed Bombay. So let me try my best to. The topic is explorative analytics, and let me share my screen. Okay, does it make sense?
Yes, sir. Welcome.
Okay. Let me know from you whether you are able to see my PPT. Are you able to see a PPT?
Yes, sir. Thank you.
Yes, sir. We can see it.
You are able to see the PPT, am I right?
Yes. Yes, sir.
Yes, sir.
So you are able to read the through. I mean, so what we are trying to address today, you see, today the whole world is moving towards, or is a technology, automation, AI, machine learning. Uh, Under that, a lot of other aspects are there. I'm just the main major terms are technology, automation, AI, machine learning. Like within automation, there could be robotic automation, there could be IoT driven automation, there could be industry 4, there are different kinds of it. So all of them are applicable there. So what I'll do actually, let me uh, explain the actual approach to data science based solutioning. Now everything comes under data science. So data science means the science behind the data analysis. Overall science behind data analysis means it could be mathematics, statistics, computer science, even economics in today's world. Okay, so what we do actually, let us understand that what do we do in this regard. So unless we understand this, so probably we won't be able to appreciate that where does this exploratory data analysis actually comes into the play, and where does it actually uh, uh, put its place, or in the sense actually how important it is in the context of overall data science or data analytics, or in today's AI machine learning. Now what happens, let us come to a practical problem. So suppose practical problem is that study a business problem. So start from the uh, right hand side bottom. So are you able to see my cursor? Study a business problem. I'm hovering my
Yes, sir.
cursor over here. Are you able to see it?
Yes, sir.
Yes, sir.
Okay. So so when we study a business problem, you see, let us understand that how does it go. Okay. For the time being, uh, let me switch off my video, because that will help me the. Okay, because if there is a bandwidth issue, then it will be so. So you are able to see the PPT again?
Yes, sir.
Yes, no? Are you
Yes,
able
sir.
to see the PPT? Okay,
Yes.
now, so what we do, okay, what we do, we start with a, let us start with a basic real problem in industry. Suppose in industry, I hope all of you have got some amount of industrial experience. Am I right? My assumption is correct?
Right, sir.
Yes, yes, sir.
Dr. Manoj? Okay. So assume that we all understand what is actually, suppose, inventory. Okay. And what is a safety stock. Okay. Now suppose I would like to uh, optimize the inventory of a retail store or manufacturing inventory store using data science driven analysis. Okay, so what happens, that means we have been told that optimize the safety stock. What is a safety stock? Now safety stock is that when actually I'll be needing in a manufacturing industry, I'll be needing the different actually items, the raw material, or it could be any unfinished products during my manufacturing process. Or in a retail, I need the store, retail store, brick and mortars, or it could be online e-commerce. I need lot of items based on the expected actually number of customers they will come in a retail store. So that means I need to maintain my inventory. While doing so, I cannot keep it exactly as it is. I expect to be sold or expect to be required for my manufacturing. So what we do, we keep a safety stock. So little bit of actually that means stock is maintained at any point of time because of any exigencies, emergency, or because of some failure, something. For example, suppose on regular basis or based on the trigger, event trigger, I I actually purchase my stock keeping units. That means the thing which will be sold or which will be used in manufacturing in an amount. Okay, expected it will be so many already used every day or every week or every month, whichever my actually stock keeping actually time period. Okay, but what happens? It may so happen my suppliers may fail to supply, or it may so happen suddenly there's a extra demand, or there could be some spoil, something may get spoiled or maybe stolen, or maybe uh, whichever way actually there may be a possibility of actually lack of actually items in the store. So for all these things, what we do, we keep a safety stock. That means that stock which may be used in emergency. So keep that in mind. Okay, now what we do after understanding that, we transform that business problem into a problem of data science, into a problem of data science. You see the next line. Are you able to see? Suppose I am writing, my cursor is here. Okay, so it
Yes,
is
sir.
a problem of
Exactly.
data science. Now, what is the problem of data science? Now, problem of data science is a mathematical problem or statistical problem of economics or problem of a deep learning. That means AI, machine learning. So, like in this context, the business problem is maintaining the safety stock. But to maintain the safety stock, I need to forecast what will be the demand in my uh, manufacturing process, or what will be demand in my retail store. So that means there's a statistical forecasting model is required to forecast my demand, based which will help me understand how much safety stock I would like to maintain. Now I do that, and the next to that is that how I'll be able to optimize it. So there's a optimization in terms of cost, because it's a business. So procurement cost is a cost. Like suppose if I order every day, if I order pin, suppose 5 or 10 number of some nuts and bolts, what will happen? Maybe that it will, inventory stock will be very thin, but problem is that there's a procurement cost, cost of transportation, and even the procurement every day. Suppose if my procurement reads suppose 10 signatures, that the approval process every day I need to go for that. So that means, and primarily the transport. So what I'll do, I'll bulk produce for a couple of days, or suppose a couple of weeks or so and so, and maybe I'll bulk, I'll procure many items together. Whenever I try to do that, there's a concept called actually optimization. Now this optimization is called the process we use, that's a EOQ, economic order quantity. So what is the amount of order I'll make, what is the most economical order of quantity. So what I'm trying to say, there's a trade-off. So keeping everything in balance, keeping all these things in place, so we try to do that. So we try to understand at macro level, at high level, what are the different components of actually uh, mathematical or statistical or economic analysis to be done, or computer science and analysis to be done. Okay. After that, you see, we need to assess the enterprise architecture. So what is the current actually architectural setup in that organization? It could be how the data are stored, where actually data will come from, what are the different processes the different departments they do, what is the operational process, what is the in the manufacturing setup, what is the quality process, what is the procurement process, all these processes. Okay, in the case of retail, suppose what is my procurement process, what is my storage process, and so what is my how do you actually forecast my predict my demands. So those are the different actually total of how the data is stored, and so and so. So for that I need for that actually I assess the enterprise architecture. At the same time, what is that we, while trying to assess the enterprise architecture, I also need to understand the where from the data will come and what is the my IT architecture. See on the left hand side, the vertical column, IT architecture. So what is that? I'll get the data from social media, whether the data will be stored in cloud, or I have got IoT, sensor, Internet of Things, sensors driven data from the data, whether they will go to the RDBMS or it will go to a big data NoSQL infrastructure. Or after that, actually, I may create a data warehouse or data lake where the data will be there for analysis, and that data will be accessed by the assess the enterprise architecture. I'll try to understand how the data is stored, how what is the overall data landscape. Once I do that, then actually there's a small mistake, so this data acquisition will come here. Okay, after that what happens, I get the data, so I acquire the data, that means I bring the data into my system. And right after that, there is a exploratory data analysis. That means I try to, after getting the data, I try to explore the data to understand that different aspects of the data. So it's a part of descriptive analytics. We'll go in details of it, but let us understand what we do after that. So let us have a overall picture of the whole ecosystem. After that, what we do, after I understand the data, as actually some part of it actually is a part of exploratory data analytics only, data engineering and preparation. And and data engineering and preparation, that means the different kinds of data engineering, data is massaged, okay, and it is prepared so that it will be useful for my development of the technical solution or development of the mathematical model or statistical model, and so and so. Okay, after that we test and analyze the result, then we transform back to the business problem. You see, initially we studied a problem and transferred the business problem into a problem of statistics, mathematics, economics, but AI, machine learning. But when we give it to the business back, we cannot give them a solution of mathematics, we have to give a business solution. So we transform the data solution, the technical solution, back to a business solution, and we implement. And while implementing that, we do give a visual dashboard. You maybe heard of that visual dashboard, visual analytics, through which actually people will be in terms of different charts or trend line or predictive model scenario chart. So those are the visual things, because will be given to the end users, and it may in today's context that may be in the mobility, that means people should be able to see in the mobile. So this is the whole aspects of the a database or data science based solutioning. And exploratory data analytics plays a vital role initially to understand what I should do, what kind of data engineering to be required, how to prepare the data, and based on that the development of the solution will be based on. Okay, next to that, let us understand that as part of it what exactly is required. So when you are trying to do the exploratory analytics, or we are doing the in data science based solutioning, so we need to understand that what is the context of the business, the way I will treat the manufacturing. Suppose I'm giving an example. Suppose a CFO of a bank, retail bank, a chief financial officer of a retail bank, the way it functions is a completely different the way chief financial officers of a manufacturing, suppose automobile car manufacturer, is works, or the way the chief financial officer of the retail. So that means everything is very domain driven, depends on the domain. So industry domain, your whole context changes, and the kind of actually analysis you require to do are they do change. Now even within the banking and financial, suppose if there's a financial work it's a retail bank, the financial manager or the CFO of a retail bank, the way it functions is a completely different. It's a stock actually wealth management or capital market guy, CFO. So that means the domain is very much required. After that, the knowledge and skill in the data science. Okay, and the third is the application of the state of the art computing or IT ecosystem or IT infrastructure. So this is the way it works. Now, this whole thing actually, what are the skills are required for your exploratory analytics, the exploratory analytics, or for data science, both, for everything actually require three kinds of stuff. One, your capability of analysis of the data, whether it is for the exploratory analytics, or we also try to understand what is predictive analytics or prescriptive analytics. We should be knowing the different skills. We should have the different skills and know the tools and techniques of statistics or mathematics based stuff. It could be as simple as that: mean, median, mode, standard deviation, range. Those are the tools also. So those are very simple. So or it could be as complex as principal component analysis or something of different stuff. Okay, another thing we should know, the domain, as I told you. So economics, because business runs on economics, business is run for the economy, and business is run in the economy. So economics, for any business you require is industry domain expertise, and the economics, and the information system data engineering, all those things. Okay, now while saying so I can skip this thing for the time being, because it is more specific to artificial intelligence and all. I'm not getting into that. But and this I slightly I'll touch on, because this is required when you are doing for exploratory data analytics. Why you are doing so? You are doing so because there are three kinds of actually data science solution. Explainable AI, that means where your explanation is required. Like suppose I am developing a data science or AI driven solution for cancer treatment or cancer detection. Okay, I should be able to explain why it is so. I'm claiming so that it is a cancer or not cancer. So I should have a mathematical explanation behind it. So in my explorative data analysis also, it is not my gut feeling. It is through data analysis. That means through some means actually. Maybe it is an average, or maybe it's a standard deviation. Maybe it is PCA, through which I'm explaining why I am thinking so. Is a probability number, whatever it may be. So it will explain. Another is the AI at scale. AI at scale is the left hand side stuff. AI at scale, actually there's a large business value, so there actually AI at scale is used. So I may not be able to explain everything. So today's deep learning based thing, suppose I may not be, it's a black box, I may not be able to explain anything, but at scale for larger business value I use it. Okay, and the third is age AI. Like suppose it has to be very accurate and a quick response. So where it is, suppose driverless car, so it is an AGI based. So after doing this, So what it is, exploratory data analytics in the context? It is the analysis of the data sets based on various numerical methods. So what is the numerical methods? So it is the central tendency. So what are the central tendency, measure of central tendencies? Suppose mean, then actually median, okay, then actually mode. So these are the way actually we go for the central tendency. Okay, so mean median mode actually are the central tendency, different kinds of, that means, you know what, I'm not getting into that, what is the mean median mode. And the next is actually dispersion. Okay, I just purposefully kept it like that so that during my uh, session actually I'll do this. Now what is mean median mode? It's a part of central tendency. Okay, okay. And then under that actually, and what is that actually dispersion? Dispersion is how the data is dispersed. So what are the things, like you might have heard of standard deviation. Standard deviation, that how what is that called, data is parsed actually, or it could be a range of data. Okay, so or sometimes it's called interquartile range. I'm not getting to each of them. Okay, another thing is that under the numerical methods is the outlier treatment. What is outlier treatment? In a data, we try to understand that if some data is actually unexpected or not, I can very well say it is not the part of this data set. Suppose it could be measurement error, it could be I could not actually instrumental error or measurement error, or some unwanted spike got into the data set. Okay, it could be different reasons. Another thing which is used in exploratory data analytics is the graphical tools. So what is the graphical tools? For any data, when actually a data scientist looks at is, these are all part of exploratory data analytics. So I am trying to explore, that means I'm trying to describe, because exploratory data analytics is a part of descriptive data science. Okay, now scattered diagram. So simply in the context of, you just in the xy plane, you try to actually plot the data and try to understand and appreciate what is happening, and through which if you are able to see some pattern and you hypothesize it, and then actually you go to inferential statistics, or what is the confirmatory statistics. So initially in the data exploratory analytics, we try to look at the data through scatter diagram, and we try to understand. Or there's a box plot. So box plot is it's actually sometime, okay, what I'll do, let me actually explain you. Are you able to see the, let me show you what is a box plot. You're able to see my Google now?
Yes, sir. Yes, sir.
Yeah, yeah. Suppose box plot. So I just would like to show you some images so that you can appreciate it. Okay, what is a box plot? So you look at it. So look at this one. Okay, look at this one. Okay, so in the box plot, suppose if the data is a normally distributed, so what happens, means and medians are, they are same. Okay, but if the data is skewed data, that means it is not exactly symmetrical, then what happens, look at it here, look at it here. So here you see, suppose there's a minimum value, there's a maximum value. So maximum minus minimum, it gives you the range, I was talking about the range. You can have a standard deviation also, but range is also a part of actually descriptive analytics. And you divide this mean minimum to maximum into 4 quadrant. So what are those quadrant? Now first medium to first lower quartile is the 25% of the data stays there. Okay, then from lower quartile to median, that means 50%, there's another 25%, another 25% here from medium mid value to quartile 3, and from quartile 3 to last one is the maximum value. This is a fourth quartile. So now if the data is normally distributed, this will be median and mean will coincide, and this will be exactly in the middle point. But assume they are not, what will happen if the more dense. That means if the tail is towards the right hand side, if the data is dense, then what will happen? This medium value will shift to, will shift towards this one, towards left hand side. So that means the more data will be here and the less data will be beyond that. So what happens? So it looks like this one. So what happens? So this is the quartile 1 and quartile 3, and this is actually the actually this is the sum meaning from the minimum value to this. So 25% of the data is there. From here to here the data is very dense. You see, it has shifted from the median value, that means mid value, towards the downward, and the quartile is over here. So that means higher the range, that means from this two quartile is actually less dense the data is. And this q1 q3 minus q1 called the interquartile range. Sometimes actually try to understand where the 50% of the data is there. So coming back to the point, my objective was to let you know. So these are the different ways actually we try to understand the how the data is, how the data actually is, the pattern of the data. So what is the behavior of the data, what is the distribution of the data. So box plot is one of the very tool actually there. So what we try to do, we explore the data for the patterns, trends, underlying structure. So box plot is the underlying structure, deviations from the trend, anomalies. Trend, what is anomalies? That is the outlier. So that means it is actually outlier means, so data is actually, outlier means the data is actually, uh, data is there's a what is that called, uh, data is not behaving very, first I'll let you know what is outlier, and then I'll tell outlier box plot. Okay, outlier, uh, outlier in scatter plot. Okay, so now images. Okay, now you see this is a trend of the data. You see this one, and here this is one point is extremely away from the main data. So this is an outlier. How this outlier will come into our stuff? Now outlier in scattered plot, if I say outlier in box plot, so in this case, if some data points goes beyond this whisker point, that means, you see this is the point. So this is the point. You see, even after minimum maximum, there are some actually, of course, I should not say minimum maxima. So generally what we do, we try to, one of the ways actually we do mu plus minus 3 sigma. Mu is the mean, and plus minus 3 sigma. Sigma is the standard deviation. If something goes beyond the negative part, that means mu minus 3 sigma, beyond that, so we say these are not actually expected data. And if something goes mu plus 6 sigma and beyond that, then those are the outliers. So outliers means there could be some uh, uh, measurement problem. There could be some, suppose every day actually we our way of working is completely different. If there's a sudden day actually earthquake, so people start work as people actually behave in a different way. Okay, so similar kind of thing actually are considered as an outlier. I'm just giving an example. Okay, so coming back to the point, so these are the things actually we do now. So now let me understand what are the different kinds of data analytics. Now descriptive analytics, under this descriptive analytics, our actually explorative analytics comes into play, because exploration is a part of once we explore, then only we'll be able to describe. Okay, so we explore by visually, by making use of different statistical tools, and based on that actually we describe. Okay, then after that, inferential analytics. So what is inferential analytics? Sometimes people say descriptive analytics, predictive analytics, prescriptive analytics, and then actually say people say, what is that called? Inferential is a sub part of inferential, descriptive, but many people like us actually believe it is in between, because through information in inferential actually we try to infer something out of the out of post actually description. Okay, or some people say that descriptive analytics is a combination of exploratory analytics and inferential analytics. Anyway, what is inferential analytics? Suppose we assume, suppose there are two companies, company A and company B. Okay. Now, company A and company B, we try to understand that what are their salaries. Okay. And we took the sample data of 1,000 employees for both of these companies. And then we plot their actually box plot. We try to understand, or we tried, we went for their normal distribution, that means, and that means their mean, average, mean or average or standard deviation, and we plotted their actually box plot also. After doing that, we are not able to understand by visual that whether actually company A and company B, the average salary, they are same or not. So we need to infer. So we develop a hypothesis. The hypothesis is that their salary is same or not same, whichever actually context, it is contextual, I'm not getting into it. So we assume it. After that, through statistical hypothesis testing, we infer that whether the salary of company A and B are same or they are different. Or we can also say that salary of company A is greater than B or less than B, whatever it may be. So that is called inferential analytics. Okay. Or giving an example, suppose there is a BPO, business call center. Okay, let's take an example of a call center. So a call center in India, it has a branch in Kolkata, Mumbai, Bombay, Chennai. Okay, and the people of different similar kind of what is that called, people are recruited everywhere at random. That means I have a process at random, in the sense I have a process, and that means no specially I have recruited different people for different places. So similar kind of people have been recruited, and suppose they are graduate and they are actually 5 years of experience or whatever it may be, similar kind of thing. After that, we try to understand whether the productivity is same in every branch, that means every centers. So we go for, if same or not, we go for. So this is a hypothesis. We prove this hypothesis by what is that called, ANOVA, analysis of variance. So that is an inferential statistic. So, and sometimes you say confirmatory statistics also, analytics also. Okay. The third is predictive analytics. What is predictive analytics? For the last 5 days or 5 months, I have a temperature pattern, and I'm going to predict based on that tomorrow's temperature or day after tomorrow's temperature or next month's temperature. Or in a stock market, so I am having a value of a, opening stock value or closing value of the stock for last 3 days, 3 months every day, and I'm going to predict it for tomorrow. Or suppose I'm trying to predict the temperature for tomorrow or rainfall for tomorrow. So it is a prediction. So, or suppose I am trying to predict that when somebody actually is taking a loan from a bank, then whether he is going to default or not. So this is also predictive analytics. What is prescriptive analytics? I recommend something. So after prediction, and prescriptive analysis is the recommending. Suppose you know that you are in the recommendation engine. Sometimes actually, Netflix and all, they recommend that this movie probably will be useful. I mean, you'll like it. Suppose that means somebody is recommending you. Or suppose I'm in the medical science, I'm recommending some actually medicine. So those are the prescriptive analysis, something like a prescription given by a doctor. Okay. So expert data analytics, what it is part of descriptive analytics. What are the data types? So data types could be nominal data, ordinal data, interval data, ratio data. What is nominal data? The nominal data is any category. Suppose nominal means anybody's name. So when you analyze something, suppose you are comparing India with Pakistan and Bangladesh and Sri Lanka. So India, when you are comparing, so India, Pakistan, they cannot be compared. They cannot be compared. So who can be compared? The compared, actually, you can compare the population of India and Pakistan, GDP of India and Pakistan, GDP per capita of India and Pakistan. Okay. So these are the things you can. So nominal is the category. It is, suppose a country is a nominal, a name is a nominal. So different category. Okay. What is ordinal? Now, ordinal could be in the exploratory data analytics. These are the things which we start with. So ordinal means when these things are in order. Suppose sometimes you give rating, evaluation rating to some services. Suppose you buy something, or your Uber, you give an rating of 1 2 3 4 5, or you give rating poor, what is that called, average, poor, average, and good and very good. So they are in order. So in the order, you cannot say one. If it is 1 2 3 4, you cannot say 2 is half of 4 or 4 is twice of 2. You cannot say so. So they are in order. So you cannot do any mathematical operations on ordinal data. You cannot do any subtraction also, because 2 minus 3 is not equal to 3 minus 1, 3 minus, sorry, 2, 3 minus 2 is not equal to 2 minus 1, in case you gave rating 1 2 3 4. Actually they are in order, but they are not, actually the intervals are not same. Interval is that where intervals makes a sense. Suppose if the interval is same, suppose the interval between two dates, suppose if there are 5 days, five consecutive days are there. So the second day minus first day is equal to the third day minus third second day. That means the amount of time elapsed between these two are same. So this is the interval time. Okay, interval solid data type. And the ratio is that where in the interval data you cannot do ratio. You cannot do ratio. That means you cannot divide an interval data. You cannot divide date with another date, isn't it? Okay, you cannot have a ratio that date divided by 2. But ratio data is, suppose your kilogram, that means your mass, your kilometer, that means your distance you have traveled. So you can half the, suppose you went 10 kilometers, you can say tomorrow I'll go 5 kilometers. So 5 kilometers half of 10 kilometer. Or you can do that I have gone 10 kilometers and another person went for 20 kilometers. So if I make the ratio, the other person actually has gone twice that of mine. So this is the different kinds of data. So another data types is the cross-sectional data, time series data, panel data. So when you do a exploratory data analysis, we need to understand the what are the different kinds of data sets. So cross-sectional data is, suppose the in the same time, what are the different data at the same time. That means like suppose at the same time the temperature, humidity, rainfall of a particular city. So they are the cross sectional data for that particular city is actually weather. Okay, so what is time series data? Time series data is that over the time the data, suppose temperature for last 30 days, so it is on the time. So each of them, each of the data points have a time lapse of actually equal interval of 1 day. So that is a time series data. And what is the panel data? Which is a combination of the cross sectional data and the time series data. So that is an advanced, very complex data. Another kind of data types you understand, that is structure, unstructured, semi-structure. So what is the structured data? Suppose in a tabular format, I have a data. Suppose the uh, height, weight, qualification, salary of each person. So that means they are in the structure you have written. There's another is unstructured data. So the data doesn't have data length, and they are not in a structured format. Suppose in a email you are sending, suppose video component, you are sending music. So these are all unstructured data. What is semi-structure? Semi-structure, it is a in-between structures. And suppose if you are aware of that, JSON is a example of the semi-structured data. We are not here to understand each of them, because only 45 minutes I'm supposed to speak. So I'll end somewhere, and then actually we'll open the platform for question. So there are two things: exploratory data analytics and the confirmatory data analytics. So what is the exploratory data analytics? So as I told you, the confirmatory is under descriptive analytics. We do exploratory data analytics. There's no hypothesis at first. That means, as I told you, that there are salaries of company A and B. So we do not develop a hypothesis that company A's salary is more than that of companies B, and we start with it. No, we do not do that. We just have the data and we try to see that how it is. We are exploring. Okay. After that, if we find that both the mean and both the standard deviations are they are same, then we say they are the same. But we are exploring, still exploring. Now we find a different many means or same standard deviation, or different standard deviation, same mean you can have. So we are exploring, we are not doing anything. So, but what is CDA, confirmatory data analysis? We start with a hypothesis. So these are different. So CDA is more for inferential, but most of the cases before CDA, before confirmatory data analysis, exploratory data analytics is masked most of the cases. Okay, so that's what the second line talks about. The EDA, exploratory data analytics, generate the hypothesis. After that, actually, we generate the hypothesis. Okay, and the CDA stands for testing the hypothesis, which actually, well, what is null hypothesis? I'm not getting into it. So there's an alternative hypothesis and null hypothesis. I'm not getting into that. And EDA uses of that graphical method is almost mandatory, and in CDA uses of the statistical models is almost mandatory. So this is the way it works. Okay, so what is actually explained in a nutshell? It is actually uh, analysis of data sets based on various numerical methods and the graphical tools, explain data for patterns, trained underlying structures, deviations from the trained anomalies, trained structures, and facilitates the discovering unexpected as well as confidently expected. So these are the things actually we do. And uh, then through exploratory data analysis, we maximize the insight into a data set. So we try to understand what is the insight of it in a using the very basic tools, and without getting into much of actually in-depth statistical inferential statistics. Okay, so uncover underlying messages, descriptive analysis, scatter diagram, box plots. That's how we saw. Yeah, and a very important thing, dimension reduction is a part of exploratory analytics. What we do actually as part of it, we try to suppose when we start with, suppose I would like to understand whether somebody will fail to repay the loan. So it's his income, his qualification, his age, his number of dependent in his family, then whether he has got some other loans or not. If you keep on doing so, you'll find thousand. I'm literally, I mean thousand, because somebody will be able to what is that called, repay the loan. That also depends on he's married or not. If he's married, his spouse is working or not. If his spouse is working, then the qualification and all the applicable factors for him also applicable for his wife. And also we may say that what is whether he has got ancestors property or not, whether his spouse has got, or a wife or husband has got ancestors properties or not. So there's no intuit factor. So what we do in the dimension reduction, when thousands or many factors are there, we try to extract the important variables. So these important variables are extracted through one is called PCA. So PCA stands for actually principal component analysis. So principal component analysis is a mathematical uh, way actually we try to find out how we can reduce the number of what is that called number of actually variables. There is another concept called actually the multicollinearity. So many a time what happens, the different variables actually, suppose I'm trying to find out y is a function of x1, x2, x3, x4, but if x1 and x2 they themselves are actually related to each other, there's a correlationship, we cannot have x1 and x2 together. So we need to find this called multicollinearity. So we need to remove one of the variables. How to do it? Through that also we are actually reducing the what is that called, dimensions, or through that also we are extracting the more important variable than otherwise. Okay, okay. So so this is what actually we do in the context of what a multicollinearity. And then we try to detect the outliers and anomalies. What happens, why we do so? Because we remove those data points, okay. So this is what actually it is. We have discussed this one. And okay, so now what I'll do, I'll leave. I know I covered 8 o'clock. So since initially we some amount of time went because of technical glitch and all. So with that actually I end it over here, and request you to should be with some questions that you have in mind.
Yes.
Yes, Dr.
Anyone
Manoj.
having any question? Yes. Yes. Anyone having any question?
I know I went very fast because only 40 minutes or 35 minutes I got it. But if I could not make sense, or you have got some questions, ask some questions which is in reality you come across, or in real life, because those are will be more important, because you'll be, you are, whatever the course you are learning for actually applying it in the industry, or applying in real practice.
So right now I don't have a question, but suppose I'd have one in the future. Do I have your permission to contact you on email?
Yeah, sure, sure. So what is there? I think in the last slide, you are able to see my slides still now. The slide is still visible.
No, right now it's not, but it was there a while ago.
Okay, so let me go back to that.
Do
So,
one thing. Take the photo of that or snap it in your computer.
Yes, I've
so
already
are
taken
you able
it
to
now.
see my are you able to see my in my contact details?
Yes, sir. It
Hello.
is visible.
Okay.
It is visible, sir.
I know it is just a kind of primer, just to. That's what I understood from Dr. Gurumurthy, that to give you a glimpse of it, and I thought these are the few things you should know. It is exploratory data analytics as just to explore. It's the nomenclature itself, name itself talks about it. The explore. You are not doing anything. You are not concluding anything. You are just trying to explore. And the next is actually inferential statistics and the predictive and prescriptive. So there actually you do the much stronger stuff. But if you have taken, so for everything we do it for uh, as part of this, okay.
Sir, insanalytics.com is your website wherein we can contact you.
It's a website. You can contact me over my WhatsApp or email. And InsAnalytics is a web. Yeah, there's a website, of course. But uh, actually, for some time, actually, I uh, I went to Ministry of Power as a chief scientist, and actually then subsequently became a freelancer. Then again, now I have come back. So the website may not be very up to date and all, and I am so hectically tied up now traveling, so I do not check it. But WhatsApp is the best, or LinkedIn will be a better platform through which actually I'll be able to contact. I mean, I should be contacted.
I see that actually when I try to open the website, the site is not secured, it says. But
We have went for SSL and all. There's something is wrong. My technical team is working on it. As I told you, very just a month and a half back actually. uh, I left my ministry job and came back, so I'm yet to actually do the homework, I mean do the actually housekeeping. So that's why actually right now actually it is better to contact me over WhatsApp and so.
sure, sure, sir. Can we also have your LinkedIn profile link? Because
LinkedIn profile link. Okay.
It is there. Actually, I searched it. It is there in the LinkedIn. LinkedIn. Yeah, it is
Uh,
there.
so this is what actually get it. I can write it in the chat, I believe. No.
yes, sir, you can copy the URL and keep it.
Yeah, I can copy it in the chat. Where is the chat? Chat. Did you get it? Have you got it?
Yes, sir. Thank you.
Okay, sir. Thank you, sir. Thank you.
Well, good.
As we wrap up this enlightening session, we extend our heartfelt gratitude to Dr. Das for sharing his invaluable insights and experiences. His expertise has truly inspired us to think differently and explore innovative solutions in the world of data science and analytics. Thank you all for your active participation and engaging questions, which made this session even more enriching. Let us take these learning forward and apply them in our respective journeys. We look forward to seeing you at our next event. Until then, stay curious and keep learning. Thank you. Thank you all.
Thank you,
And
Dr.
thank you,
Manoj.
Dr.
Thank you,
Sir.
all the
Dr. Sir.
participants.
Thank you, sir. Yeah, it's a great session. Thank you, sir.
Thank you.